Hello friend, we are looking at pressure drop calculation. So if you remember in distillation column, we have assumed P top and we have assumed pressure drop on every plate. If you remember, it was 100 mm of water. So we want to check out whether this pressure drop assume is correct. So there are different types of pressure drop. So one is because of the height of weir. Yes, the weir is responsible for the liquid pool buildup on the plate. So this is one. Second, when actual flow happens, it goes above the weir. So this is the additional weir height, which is HOW, which will be responsible for pressure drop. Third is dry plate drop. So from the hole, when vapor goes, there is a contraction, which will cause a pressure drop. And the fourth one is residual head that depend on a density of liquid. So HW, so total pressure drop is HW, height of weir, because of additional weir height, then the dry plate pressure drop and residual pressure drop based on liquid density. So let's start with, so HW and HOW we have found out last time. I hope this was a function of weir length, the liquid velocity, sorry, liquid flow rate and density of liquid, which you have seen in last check. This was HOW based on liquid flow rate, length of weir, density of liquid. Yes. HW we have assumed to be 50 mm. This has come for around 20 mm, 22 mm. Now let's find out dry plate pressure drop. So here, this is the velocity of vapor, which we found out last time. This will give us UH, minimum vapor velocity. That is okay. So this calculation we have done for whipping. So use the same calculation here. So UH is done. Here you require CO, coefficient of orifice. Now coefficient of orifice, you can look it from a graph. It is based on area of hole to area of plate. This parameter. So this was taken on active area divided area of hole to active area was taken 10%. And intermediate, we have plate thickness versus hole diameter. So we have taken hole diameter of hole to be 5 mm. Plate thickness also recommended to be around 5 mm thickness of plate. So this become 1. Correct? This is most recommended thing, that this ratio is 1. So AH by AP, active area to hole, is 10%. You just go up from here until it meets the line of diameter of plate thickness to diameter of hole equal to 10. Go on left hand side, you will get CO. So here CO comes to be around 0.83. Substitute this here. There is a density of vapor, density of liquid. You will get diameter of dry plate pressure drop. So this you can do for top section, bottom section. So we have, this would be higher on bottom side. So we are considering all the values for bottom section, stripping section. This will give me dry plate pressure drop in mm. Density is the ratio, so no problem. This is in meter per second. CO is a coefficient, no unit. And residual head is based on density of liquid. Substitute density of liquid in a stripping section, which will give you a total pressure drop. Now this pressure drop, if let's say this total pressure drop comes to be 120 mm, then to go back, substitute this 100 mm with 120 mm, redo the whole calculation, check out the P bottom pressure, and all the densities will change, number of the diameter and everything will change, and then you redo to check out whether the assumed and actual pressure drop is correct. If that is correct, then this design is perfect. Thank you so much.